As you rest peacefully tonight, beneath a sky filled with stars, contemplate humanity's oldest and most profound question. Are we alone in the universe? Look up through the darkness toward the countless points of light scattered across the heavens, and know that each one is a sun, potentially surrounded by worlds where chemistry might have become biology, where evolution might have created consciousness, where other beings might at this very moment be looking up at their own night sky, wondering if anyone else exists among the stars. This question has haunted and inspired humanity throughout our entire existence. Ancient peoples looked at the stars and imagined them as homes for gods and spirits. Medieval scholars debated whether God's creation extended beyond Earth. Modern scientists approach the same question with telescopes, spacecraft, and sophisticated understanding of chemistry, physics, and the conditions necessary for life. And what they've discovered is simultaneously humbling and thrilling. Tonight, as you drift towards sleep, you'll journey through the scientific search for extraterrestrial life, discovering not wild speculation, but careful reasoning based on evidence, probability, and our growing understanding of how common the ingredients for life appear to be throughout the cosmos. You'll learn why many scientists believe we may not be alone, why others remain uncertain, and why the question itself reveals so much about what makes us human. The universe you inhabit is almost incomprehensibly vast. Our Milky Way galaxy contains between 100 and 400 billion stars, and astronomers estimate there are roughly 2 trillion galaxies in the observable universe. If even a tiny fraction of those stars host planets where life could emerge, the number of potential worlds harboring biology could be astronomical. Perhaps billions or even trillions of living worlds scattered throughout space and time. This statistical perspective, often called the principle of mediocrity or the Copernican principle, suggests that Earth is unlikely to be unique. We orbit an ordinary star in an ordinary spiral galaxy in an ordinary region of the universe. The chemical elements that make up your body, carbon, hydrogen, oxygen, nitrogen, are among the most common elements in the cosmos. The laws of chemistry that allowed life to emerge on Earth operate identically throughout the universe. Yet despite decades of searching, we have found no definitive evidence of life beyond Earth. No radio signals clearly indicating alien intelligence. No spacecraft visiting our solar system. No biological signatures in the atmospheres of distant planets, at least not yet. This absence of evidence has led to what physicist Enrico Fermi famously framed as a paradox. If alien civilizations are likely to exist, where is everybody? The possible answers to Fermi's question range from the pessimistic to the hopeful. Perhaps life is extraordinarily rare, requiring such specific conditions that Earth represents a cosmic fluke. Perhaps life is common, but intelligence is rare. Perhaps intelligent civilizations exist, but remain too distant for communication. Or perhaps they're actively avoiding contact. Or perhaps civilizations inevitably destroy themselves before achieving interstellar communication. Or perhaps, and many scientists find this possibility most likely, we simply haven't searched long enough or looked in the right places yet. The universe is 13.8 billion years old, but humanity has been actively searching for alien signals for only about 60 years, roughly 1/billionth of cosmic history. We've examined only a tiny fraction of possible star systems, using technology that improves dramatically each decade. As you rest tonight, scientists around the world continue this search. Radio telescopes scan the skies for artificial signals. Space telescopes study the atmospheres of distant planets for chemical signatures that might indicate biological processes. Robotic rovers explore Mars, searching for fossils of ancient microbial life. Spacecraft prepare to visit the icy moons of Jupiter and Saturn, where liquid oceans beneath frozen surfaces might harbor alien ecosystems. The search for extraterrestrial life represents humanity at its most hopeful and curious, asking questions not because we fear the answers, but because we hunger for knowledge, because we want to understand our place in the cosmos, because discovering we're not alone would fundamentally change our understanding of what it means to be alive, conscious, and human. Tonight's journey will take you from the possibility of microbial life in our own solar system to the search for intelligent civilizations among the stars. From the chemical building blocks that seem universal throughout space to the profound philosophical implications of contact with alien minds, you'll discover why the search for alien life is not science fiction but serious science, pursued by thousands of researchers using increasingly sophisticated methods to answer the question that has defined human wonder since we first looked up at the night sky. Rest now in contemplation of this cosmic question, knowing that every star you've ever seen might host worlds where the universe has become aware of itself through different forms, different chemistries, different evolutionary paths, and that the answer to whether we're alone, whatever it turns out to be, will reveal profound truths about the nature of life, consciousness, and the remarkable universe we call home. Life's universal recipe, the chemistry that connects us to the cosmos. Descend now into the molecular realm where life begins, discovering that the basic ingredients necessary for biology appear to be remarkably common throughout the universe, suggesting that the chemistry that created you might be unfolding on countless worlds across the cosmic ocean. Life on Earth, in all its magnificent diversity, follows chemistry based on carbon atoms linking together to form complex molecules. Carbon's unique ability to bond with itself and other elements in countless configurations makes it chemistry's most versatile building block, capable of creating the proteins, nucleic acids, and other complex molecules that constitute living organisms. And carbon is the fourth most abundant element in the universe, forged in the nuclear furnaces of stars and scattered throughout space by stellar winds and supernova explosions. The water that comprises roughly 60% of your body serves as life's universal solvent, the medium in which biological chemistry unfolds. Water's unusual properties, remaining liquid across a wide temperature range, dissolving both polar and non-polar molecules, expanding when frozen, make it nearly ideal for supporting the complex chemistry of life. And water appears to be extraordinarily common throughout the cosmos, detected in interstellar clouds, on asteroids and comets, in the atmospheres of distant planets, and potentially as vast subsurface oceans on multiple moons in our own solar system. The amino acids that build your proteins, the nucleotide bases that encode your genetic information. These complex organic molecules have been found in meteorites that have fallen to Earth, created by non-biological processes in the chemistry labs of space itself. The famous Murchison meteorite, which fell in Australia in 1969, contained over 70 different amino acids, demonstrating that the building blocks of life form naturally wherever the right chemical ingredients and energy sources exist. Radio telescopes detecting molecules in interstellar space have found a cosmic chemistry set that includes ethanol, drinking alcohol, formaldehyde, and even complex organic molecules containing rings of carbon atoms. Space is not empty, but filled with the chemical precursors to biology, suggesting that the universe itself is a vast laboratory where organic chemistry experiments have been running for billions of years across countless stellar systems. The 6 most common elements in living organisms on Earth: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, sometimes remembered by the acronym CHNOPS, are all common throughout the universe. This suggests that if chemistry evolves toward complexity, and eventually biology, elsewhere, it might use the same basic ingredients that created you, following similar chemical pathways toward increasingly sophisticated molecular organization. Energy sources that could drive alien biochemistry appear ubiquitous throughout space. Sunlight bathes the surfaces of countless planets in the habitable zones around their stars. Volcanic activity and hydrothermal vents could provide chemical energy in subsurface oceans. Tidal forces could generate heat in moons orbiting giant planets. Radioactive decay could warm planetary interiors for billions of years. Wherever liquid water and organic chemistry exist together with available energy, the potential for life exists. Scientists have discovered that life on Earth can thrive in conditions once thought impossible. In boiling hot springs, in Antarctic ice, in rocks miles beneath Earth's surface, in the crushing pressures of the deepest ocean trenches, in highly acidic or alkaline waters, even in the vacuum of space temporarily and intense radiation. This extremophile life expands the range of conditions we consider potentially habitable, suggesting that alien life might exist in environments very different from Earth's comfortable surface. The timeline of life's emergence on Earth provides another encouraging data point in the search for extraterrestrial biology. Chemical evidence suggests that life appeared on Earth remarkably quickly after the planet cooled enough to maintain liquid water, perhaps as early as 4.1 billion years ago, when Earth was less than 500 million years old. This rapid emergence suggests that given the right conditions, chemistry naturally organizes itself into biology without requiring extraordinarily lucky circumstances. Laboratory experiments have demonstrated that exposing simple chemical ingredients, methane, ammonia, water, hydrogen, to energy sources like lightning or ultraviolet radiation can produce amino acids and other organic molecules crucial for life. The famous Miller-Urey experiment of 1952 showed this organic synthesis could occur spontaneously from simple precursor chemicals, supporting the hypothesis that life's building blocks form naturally wherever conditions permit. Recent discoveries of organic molecules on Mars, detected by the Curiosity rover, suggest that complex carbon chemistry once occurred on the red planet when it possessed liquid water on its surface billions of years ago. Whether this chemistry ever crossed the threshold into biology remains unknown, but the presence of organic molecules on a world other than Earth demonstrates that the chemistry of life is not unique to our planet. The detection of phosphine gas in Venus's atmosphere, though controversial and still being investigated, raised the tantalizing possibility that even in Venus's hellish clouds, some form of chemistry might be occurring that on Earth is associated primarily with biological processes. Whether this represents actual life or some unknown non-biological chemistry, it demonstrates that planets can surprise us with unexpected chemical activity. As you rest peacefully tonight, feel yourself connected through chemistry to the entire cosmos. The carbon atoms in your body were forged in stars that existed before our solar system formed. The hydrogen atoms in your water molecules date from the first moments after the Big Bang. You are made of cosmic matter that has been cycling through space for billions of years, and that same matter exists throughout the universe, potentially organizing itself into life wherever conditions permit the chemistry of complexity to unfold into the biology of existence. Worlds of possibility, where life might exist in our cosmic neighborhood. Journey now through our solar system and beyond, discovering the surprising number of worlds where conditions might support life, from the familiar rocky planets to exotic moons with subsurface oceans, from the scorching inner system to the frozen reaches where sunlight barely reaches, but chemical energy might still support alien ecosystems. Mars, Earth's smaller, colder neighbor, represents the most obvious place to search for life beyond our planet. Billions of years ago, Mars possessed liquid water on its surface. Rivers carved channels through ancient terrain. Lakes filled impact craters, and a northern ocean may have covered much of the planet's lowlands. This ancient wet Mars could have supported microbial life. And if life emerged during Mars's wet period, hardy microorganisms might still survive in subsurface aquifers or ice deposits, protected from the harsh surface radiation. The Curiosity and Perseverance rovers have found organic molecules, detected methane gas appearing seasonally in Mars's thin atmosphere, and discovered ancient lake beds where conditions might have been suitable for life billions of years ago. Perseverance is currently collecting samples from Jezero Crater, an ancient river delta, which future missions will return to Earth for detailed analysis that could reveal fossil evidence of ancient Martian biology. But Mars is just the beginning of potentially habitable worlds in our solar system. Europa, Jupiter's ice-covered moon, has become one of the most exciting targets in the search for extraterrestrial life. Beneath Europa's frozen surface lies a global ocean containing more water than all of Earth's oceans combined, kept liquid by tidal heating from Jupiter's immense gravity. This subsurface ocean might have existed for billions of years, potentially providing stable conditions where life could emerge and evolve in complete darkness, perhaps around hydrothermal vents similar to those that support diverse ecosystems on Earth's ocean floor. Enceladus, Saturn's small, icy moon, has been caught in the act of spraying water into space from geysers that erupt through cracks in its southern ice. The Cassini spacecraft flew through these plumes and detected not just water, but also organic molecules, salts, and evidence of hydrothermal activity, essentially all the ingredients necessary for life. Enceladus might harbor a subsurface ocean where microbial life could exist, fed by chemical energy from interactions between water and the moon's rocky core. Titan, Saturn's largest moon, presents perhaps the most exotic, potentially habitable environment in the solar system. Its thick nitrogen atmosphere and liquid hydrocarbon lakes and seas create conditions utterly unlike Earth. Yet Titan's rich organic chemistry and available energy sources raise the tantalizing possibility of life based on different chemistry than Earth's water-based biology. Titan might support weird life, using liquid methane or ethane as a solvent instead of water, breathing hydrogen instead of oxygen, metabolizing acetylene instead of glucose. Even more distant worlds might harbor life. Pluto, revealed by the New Horizons flyby to be geologically active despite its great distance from the Sun, might possess a subsurface ocean kept liquid by radioactive decay and tidal heating from its large moon Charon. Other moons of the outer solar system, Ganymede, Callisto, Triton, might also hide liquid water beneath frozen surfaces. Beyond our solar system, the search for habitable worlds has been revolutionized by the discovery of exoplanets, planets orbiting other stars. The Kepler Space Telescope discovered that planets are common, with statistical analysis suggesting that most stars in our galaxy host planetary systems. Many of these exoplanets orbit in their star's habitable zone, the region where temperatures could allow liquid water to exist on planetary surfaces. The TRAPPIST-1 system, a red dwarf star 40 light-years away, hosts 7 Earth-sized planets, 3 of which orbit in the habitable zone. The Proxima Centauri system, our nearest stellar neighbor just 4.2 light-years distant, includes at least 1 planet in the habitable zone around its red dwarf star. These nearby potentially habitable worlds represent prime targets for future searches for biosignatures, chemical signs of life in planetary atmospheres. The James Webb Space Telescope and other next-generation observatories are beginning to study the atmospheres of exoplanets, searching for combinations of gases that might indicate biological activity. On Earth, oxygen makes up 21% of our atmosphere, primarily because photosynthetic organisms produce it continuously. Without life, chemical reactions would quickly remove atmospheric oxygen. Finding oxygen, especially in combination with methane, another gas that life produces but that reacts away quickly, might indicate biological activity on distant worlds. Some scientists propose even more exotic possibilities for life. Rogue planets, ejected from their birth stellar systems and wandering through interstellar space in eternal darkness, might maintain subsurface oceans through radioactive decay and retain atmospheres that trap heat. Brown dwarfs, failed stars too small to sustain nuclear fusion, might host atmospheric chemistry that could support airborne organisms in their warm upper layers. The concept of the habitable zone has expanded as our understanding of life's possibilities has grown. We once thought planets needed to be Earth-like and orbit Sun-like stars. But now we recognize that life might exist in subsurface oceans on worlds far outside traditional habitable zones, might thrive around red dwarf stars that comprise 75% of all stars in the galaxy, might develop in the atmospheres of gas giants, or might survive in environments we haven't yet imagined. As you drift toward sleep, feel yourself surrounded by a solar system and galaxy filled with worlds of possibility. From Mars's ancient lake beds to Europa's deep oceans, from Titan's exotic chemistry to potentially habitable exoplanets circling nearby stars. We may already live in a cosmic neighborhood teeming with microbial life, with alien ecosystems existing beneath ice, in darkness, using chemistry both familiar and strange, waiting to be discovered by our increasingly sophisticated search for biology beyond Earth. Messages across the cosmos, the search for intelligent life. Contemplate now the possibility that somewhere among the stars, intelligence has emerged as it did on Earth, conscious minds asking questions, developing technology, looking out into space and wondering if they're alone, perhaps even attempting communication with civilizations like ours across the vast distances that separate stars. The search for extraterrestrial intelligence, known as SETI, represents humanity's systematic attempt to detect signals from alien civilizations. Since 1960, when astronomer Frank Drake first pointed a radio telescope toward nearby stars to listen for artificial signals, scientists have been scanning the skies for radio waves, laser pulses, or other electromagnetic signals that might indicate the presence of technological civilizations. Radio waves can travel across interstellar distances at the speed of light, making them ideal for communication between stars. A sufficiently powerful radio transmitter on a planet orbiting a star 100 light-years away could send signals that our radio telescopes could detect, though we would be receiving a message sent a century ago, and any response we sent would take another century to reach them. This time delay makes interstellar conversation impractical, but it allows for the transmission of vast amounts of information about each civilization's science, culture, and history. SETI researchers primarily search for narrow-band radio signals, transmissions focused on a specific frequency rather than spread across a broad range, because such signals would be very unlikely to occur naturally and would indicate artificial origin. The cosmos generates plenty of radio noise from stars, pulsars, and other natural sources. But these natural emissions spread across many frequencies, whereas a deliberate signal would likely concentrate its energy at one frequency to maximize its detectability. The famous WOW signal, detected in 1977 by Ohio State University's Big Ear radio telescope, remains one of the most intriguing candidate signals ever detected. The signal's characteristics: its narrow bandwidth, its intensity 30 times stronger than background noise, its apparent origin from outside our solar system, matched what SETI researchers expect from an artificial transmission. Yet, despite decades of subsequent searches, the signal has never repeated, leaving its origin a tantalizing mystery. Modern SETI searches scan millions of radio channels simultaneously, using sophisticated software to distinguish potential artificial signals from natural radio emissions and human-generated interference. Projects like Breakthrough Listen, funded by technology entrepreneur Yuri Milner, use the world's most powerful telescopes to search thousands of nearby stars for any signs of technological activity, conducting the most comprehensive SETI searches ever undertaken. Scientists also search for optical SETI signals, brief but intense laser pulses that an advanced civilization might use for interstellar communication. A sufficiently powerful laser could outshine its parent star for nanoseconds, creating a beacon visible across interstellar distances to civilizations with telescopes powerful enough to detect the brief flash. The famous Drake equation, formulated by Frank Drake in 1961, attempts to estimate the number of communicating civilizations in our galaxy by multiplying together factors like the rate of star formation, the fraction of stars with planets, the number of habitable planets per stellar system, the fraction where life emerges, the fraction where intelligence evolves, and the length of time civilizations remain detectable. The equation cannot give precise answers because many factors remain unknown, but it provides a framework for thinking systematically about the probability of alien civilizations. Some factors in the Drake equation have become much better constrained since 1961. We now know that planets are common and that many orbit in habitable zones, but other factors remain deeply uncertain. What fraction of habitable planets actually develop life? What fraction of life-bearing worlds evolve intelligence? How long do technological civilizations typically exist before destroying themselves or evolving beyond radio communication? If we are the only intelligent civilization currently active in our galaxy, it might be because intelligence is extraordinarily rare, requiring such an unlikely sequence of evolutionary events that Earth represents a cosmic fluke. Or it might be because intelligent civilizations are common but short-lived, destroying themselves through war, environmental catastrophe, or other self-inflicted disasters before achieving long-term stability and interstellar communication. Alternatively, intelligent civilizations might be common but deliberately quiet, choosing not to broadcast signals that might attract dangerous attention from more advanced civilizations. This dark forest hypothesis suggests the universe might be full of civilizations maintaining radio silence, all wary of revealing their presence to potential threats. Or perhaps advanced civilizations communicate using technologies we haven't discovered yet, making them invisible to our current searches. The Fermi paradox. If intelligent aliens are likely to exist, where is everybody? Has generated dozens of possible explanations, ranging from the pessimistic to the hopeful. Perhaps we're first, the earliest technological civilization in our galaxy. Perhaps we're last, arriving after all other civilizations have gone extinct. Perhaps interstellar travel and communication are far more difficult than science fiction suggests, making galactic civilizations physically impossible. Or perhaps, and many scientists find this increasingly likely, civilizations exist but remain too distant for easy detection. Our galaxy is 100,000 light-years in diameter, containing hundreds of billions of stars. Even if thousands of civilizations exist, they might be separated by such vast distances that detecting their signals requires better technology than we currently possess, or longer search times than the few decades we've been looking. Humanity has also sent messages to the stars, though these efforts remain controversial. The Arecibo message, transmitted in 1974 toward a globular star cluster 25,000 light-years away, contained information about human biology, DNA structure, the solar system, and the Arecibo telescope itself, encoded in binary and transmitted at radio frequencies. More recently, messages to extraterrestrial intelligence, METI, have been sent toward nearby stars, though some scientists worry about the wisdom of actively advertising our presence before understanding the potential risks. As you rest peacefully tonight, radio waves carrying television and radar signals from Earth are expanding into space at the speed of light, creating a bubble of human-generated radio emissions now extending roughly 100 light-years from our planet. Any civilization with radio telescopes within that sphere could potentially detect evidence of technological activity on Earth, though they would be receiving signals from Earth's past, seeing our world as it was decades ago when those signals first left our planet. Sleep knowing that the search for extraterrestrial intelligence continues around the world, with dedicated scientists and citizen scientists analyzing data, scanning the skies, hoping to detect that first confirmed signal that would prove we're not alone. A discovery that would rank among the most profound in human history, fundamentally transforming our understanding of life, intelligence, and our place in the cosmic community. Contact and consequences. What finding life would mean. Imagine now the moment when humanity receives definitive proof that we are not alone, whether the discovery of microbial fossils in Martian rocks, biosignatures detected in an exoplanet's atmosphere, or the reception of an unmistakable artificial signal from another civilization among the stars. How would such a discovery change us? What would it mean for science, philosophy, religion, and the human self-understanding that has always placed us at the center of existence? The discovery of even simple microbial life beyond Earth, whether extinct organisms on Mars or living microbes in Europa's ocean, would represent one of the most significant findings in the history of science. It would answer the question of whether life emerges readily wherever conditions permit, or whether Earth represents a singular fluke. If life emerged independently twice in one solar system, it would strongly suggest that biology is common throughout the universe, that the cosmic ocean likely teems with living worlds, and that life may be a fundamental feature of the universe rather than an extraordinarily rare accident. Finding alien microbes would also allow scientists to study an independent example of biology, revealing whether Earth's particular solutions to life's challenges, DNA, RNA, proteins, cellular membranes, represent universal necessities or just one possibility among many that evolution might explore. Alien microbes might use different genetic molecules, different amino acids, different cellular architectures, or even different fundamental chemistry, revealing that life's possibilities extend far beyond the single example we know from Earth. The detection of biosignatures in an exoplanet's atmosphere would similarly confirm that life exists beyond Earth, though without providing detailed information about its nature. The James Webb Space Telescope and future observatories may detect atmospheric oxygen, methane, or other gases in combinations that on Earth result from biological activity. Such a detection couldn't prove that life exists on these distant worlds, but it would identify prime candidates for more detailed study and potentially narrow our understanding of where to focus the search for extraterrestrial biology. Contact with an intelligent alien civilization would carry far more profound implications for human self-understanding. Throughout history, humans have imagined ourselves as the pinnacle of creation, the species for whom the universe exists, the inevitable culmination of cosmic evolution. The discovery of alien intelligence would definitively prove that we are not unique, not central, not the universe's only way of becoming conscious of itself. The philosophical and religious implications of contact would be profound and varied. Some religious traditions might easily accommodate alien life within their theological frameworks, viewing extraterrestrial beings as part of God's diverse creation. Others might face more challenging theological questions about alien souls, salvation, sin, and the relationship between humanity's religious narratives and beings whose evolutionary history occurred entirely separately from our own. The reception of an alien signal would immediately raise questions about the civilization that sent it. How advanced are they compared to humanity? What is their understanding of physics, mathematics, biology? What can they tell us about their history, culture, philosophy? What warnings might they offer about challenges that civilizations face as they develop advanced technology? What might they know about other civilizations in the galaxy? Scientists have developed protocols for what to do if a genuine alien signal is detected. The first step would be verification, confirming that the signal is truly of alien origin, rather than human-generated interference or some unexpected natural phenomenon. This verification would involve observations by multiple telescopes in different locations, carefully documenting the signal's characteristics and ruling out all possible terrestrial or natural explanations. Once verified, the discovery would be announced to the world through international scientific channels and the United Nations, which has established a committee to coordinate international responses to contact with extraterrestrial intelligence. The information would belong to all humanity, not to any single nation, institution, or individual, representing a discovery of universal significance that transcends borders and belongs to the entire human family. Whether humanity should attempt to respond to an alien signal remains a subject of intense debate among scientists and ethicists. Some argue that we should respond, seeing the opportunity for interstellar dialogue as too valuable to pass up, despite the decades or centuries it would take for messages to travel between stars. Others counsel caution, noting that we cannot know the intentions of an alien civilization, and that broadcasting our presence might carry unknown risks. The content of any message we might send to alien civilizations raises equally complex questions. What should we tell them about ourselves? Should we present humanity's achievements in science, art, and culture, or acknowledge our struggles with war, inequality, and environmental destruction? Should we transmit information about Earth's location and our level of technological development, or maintain some strategic ambiguity about our capabilities and vulnerability? Some scientists and philosophers worry about the potential for malevolent alien contact, though others note that any civilization capable of interstellar communication would likely have solved the social and technological problems that create conflict within their own society. A civilization that destroys itself through war or environmental catastrophe would never achieve the stability necessary for long-term space exploration and communication, suggesting that any aliens we might contact would have overcome the challenges that currently threaten our own civilization. The possibility of direct alien visitation to Earth remains extremely unlikely, given the vast distances between stars and the enormous energy requirements for interstellar travel. Even if aliens exist, even if they know about Earth, the nearest potentially habitable planets are light years away, distances that would require either impossibly long journey times or technologies far beyond our current understanding of physics. The UFO sightings that periodically capture public attention have never yielded evidence that survives rigorous scientific scrutiny. As you drift towards sleep, contemplate what contact with alien life, whether microbial or intelligent, would mean for humanity. Would we see ourselves differently, more clearly recognizing our common humanity in contrast to beings whose evolutionary history followed entirely different paths? Would we become more unified as a species, recognizing that our internal divisions pale in comparison to the gulf separating us from alien minds? Would we find comfort in the knowledge that consciousness is not unique to Earth, that the universe has created other forms of awareness with whom we might someday share knowledge, art, philosophy, and the profound experience of being alive and aware in the cosmos? The cosmic perspective, what the search itself reveals. Rest now in contemplation of what the search for extraterrestrial life reveals about humanity itself, our capacity for wonder, our hunger for knowledge, our deep desire for connection and understanding, and the remarkable journey of self-discovery that unfolds as we search the cosmos for others who might share our questions about existence, meaning, and the nature of consciousness in the universe. Whether or not we ever discover alien life, the search itself has already transformed our understanding of our place in the cosmos. The discovery of exoplanets has revealed that worlds are common, that planets orbit most stars in the galaxy, that Earth is not unique but one example of a general category, rocky worlds in habitable zones, potentially numbered in the billions throughout our galaxy alone. This expanding cosmic perspective has forced us to confront our assumptions about life's requirements and possibilities. We once thought life required conditions very similar to Earth's surface environment, but the discovery of extremophiles and subsurface ocean worlds has revealed that biology might thrive in conditions we once considered completely hostile to life. The search for alien life has expanded our understanding of life itself, revealing previously unknown possibilities for how chemistry can organize itself into biology. The search has also driven technological innovation. The telescopes, spectrometers, rovers, and analytical techniques developed to search for biosignatures and study distant worlds have applications far beyond astrobiology. The same technologies that help us search for methane on Mars or analyze exoplanet atmospheres also help us monitor Earth's own atmosphere, track climate change, and understand our own planet's complex systems. More profoundly, the search for alien life has revealed something essential about human nature: our capacity for hope, our willingness to invest time and resources in questions that may not yield answers during our lifetimes, our ability to contemplate possibilities that transcend immediate practical concerns. The search for extraterrestrial intelligence might be the most optimistic scientific endeavor ever undertaken, based on the hope that consciousness has arisen elsewhere, that communication across interstellar distances is possible, and that the universe contains minds capable of appreciating each other's existence, despite vast separations in space and time. Carl Sagan eloquently expressed this perspective when he noted that the search for extraterrestrial intelligence is really a search for ourselves, for understanding what it means to be conscious, technological beings in a vast cosmos, for recognizing our common humanity in the face of cosmic perspective, for appreciating the precious fragility and beauty of our pale blue dot suspended in a sunbeam. The question of whether we're alone also prompts profound philosophical reflection on consciousness, intelligence, and the nature of mind. If we are alone, if Earth is the only planet in the galaxy or even the universe where matter has organized itself into conscious awareness, then we carry an awesome responsibility as the universe's only means of experiencing its own existence. Our extinction would represent not just the loss of human civilization, but the loss of consciousness itself from the cosmic stage. If we are not alone, if life and intelligence have emerged on countless worlds, then we participate in a cosmic community of minds, each one a unique perspective on existence, each one valuable and irreplaceable, despite being part of a larger pattern of consciousness distributed across space and time. In this scenario, finding alien life would not diminish human importance, but would reveal us as part of something grander, members of a universal community of conscious beings. The temporal dimension of this question adds additional complexity. Civilizations might be common, but exist at different times, arising and falling across billions of years of galactic history, perhaps never overlapping in ways that permit communication. We might live in a galaxy where countless civilizations have existed, where many will exist in the future, but where simultaneous existence of communicating civilizations is rare, leaving each one to discover evidence of others only through archaeological traces, ancient signals, abandoned structures, or biosignatures from worlds where life once flourished but no longer exists. Some scientists propose that we might be living in a universe where consciousness is just beginning to emerge, where Earth represents one of the first worlds to produce technological civilization, where the future will see countless others arising across billions of years to come. In this view, humanity might have a special role as one of the earliest conscious species, potentially seeding knowledge, or even life itself, across the galaxy for future beings to discover. Others suggest that consciousness might be a late-stage phenomenon in cosmic evolution, that we live in a universe that has already seen countless civilizations rise and fall, that we are learning to search for aliens billions of years after the galaxy's golden age of communicating civilizations has passed. In this more melancholy view, we might be alone not because consciousness is rare, but because we arrived too late to join the cosmic conversation. The truth is that we simply don't know yet. We have one data point, Earth, and from a single example, we cannot determine whether life is common or rare, whether intelligence is inevitable or extraordinary, whether the universe teems with minds or remains mostly unconscious across vast reaches of space and time. The only way to answer these questions is to continue searching, to build better telescopes, to explore more worlds, to listen longer and more carefully to the cosmic radio spectrum. As you sleep tonight beneath the stars, rest in the knowledge that whether we are alone or part of a cosmic community, your existence is remarkable and precious. You are matter that has become aware of itself, chemistry that has learned to ask questions about chemistry, consciousness that can contemplate consciousness, your capacity for wonder, for curiosity, for love and hope and meaning-making. These aspects of human experience would be valuable and remarkable, whether they are unique in the universe or part of a pattern repeated on countless worlds. The search for alien life continues in laboratories and observatories around the world, driven by curiosity and hope, by the profound human need to understand our place in the cosmos. Whether that search ultimately reveals we are alone or part of something greater, the journey itself ennobles us, revealing humanity at its best, curious, hopeful, rational, and capable of contemplating questions that extend far beyond immediate survival to touch on the deepest mysteries of existence itself. Sleep peacefully, cosmic citizen, knowing that you lived during the first generations of humans who possessed the technology to seriously search for life beyond Earth, who might, within your lifetime, discover that we are not alone, who participate in humanity's greatest and most profound question, as it transitions from ancient philosophical speculation to modern scientific investigation, capable of providing definitive answers. Sweet dreams beneath the stars, where answers wait to be discovered, where mysteries deepen our appreciation of existence, and where the question of whether we're alone continues to inspire the noblest aspirations of the human spirit, seeking connection, knowledge, and meaning in the vast, beautiful, perhaps living cosmos that is our eternal home.